Hello everyone, thank you very much. What an exciting day. We've had like basically a whole day of Gleam talks, an entire Gleam track. Who would have thought it? Very exciting and lovely to see you. And those at home, hello. This talk is called OTP and Gleam. I want to sort of show a little bit of how those two big things work together and explain, well, can they work together? What are the problems? What are the challenges? And sort of take a little look inside it and see why the decisions have been made the way they have been. Just because that's fun. And also, I think that context helps you understand the system a little bit more. Oh, I didn't press start on my timer. Oh, well. So why am I here talking about this? I'm Louis. I made Gleam, so that's why they let me do this. Fools. So let's talk about OTP. What is OTP? Because it's a bit confusing, I think. It's a little bit hard to understand what precisely it is when you start in the BEAM mod. You know it's important because everyone gets very excited about it, but I don't know, it's the open telecom platform. That name doesn't really mean anything. It's not really clear what bits are Erlang and which bits are OTP. It's a strange thing. And I think to understand it best, you need to take a little bit of a step back and look at the BEAM as a whole. So the BEAM gives us, and we like to boast about these things, it gives us massive scalability, unmatched reliability, production observability, reliable low latency ability, and distributed computing. Right? These are all fantastic things that we like to boast about. Or does the BEAM actually give us these things? I don't think it does. It doesn't give us massive scalability. It gives us messages. It doesn't give us unmatched reliability. It gives us error isolation. And you can see the relationship between these things, and you can see how it helps you make those properties, but just having one doesn't necessarily mean you have the other. It's our job to take those primitives, those useful tools, and turn it into a system that has the properties that we want to boast about as Beamers. It's very easy to make a mistake if you just start with those small little building blocks and try and build up. You know, it's still very challenging stuff, especially once you're dealing with concurrency and that sort of thing. So, and I think that's what the BEAM is really. The BEAM is a collection of code that, OTP is a collection of code that comes with your Erlang distribution most likely, and it takes those BEAM primitives and it implements a bunch of really useful design patterns to give us a bunch of building blocks that we can use inside our programs. Supervisors, gen servers, all that sort of stuff. And because these implementations have been built by brilliant people and thoroughly tested and used over nearly 30 years now, we know that we can rely on them. The problems have been found both with the design and the specific implementation. Fantastic. We don't need to solve these problems again. And because we have these building blocks, we can build things much faster. We don't have to start from scratch. And because we're all familiar with these building blocks, we end up with a shared language. I can talk to you as another Beamer, and even though we're working in a different code base, or maybe you've recently joined my team, or I've recently joined your company, we have the capability to reason about our programs and communicate about them because you know what a supervisor is, you know what it does. I know what a gen server is. And the last piece of what OTP is, which I think we don't talk about quite so much, is it's a set of protocols, a set of interfaces. And things that implement these interfaces can slot into the wider OTP system. So special processes that respond to system messages, modules that implement callbacks for some module behavior, that sort of thing. So that's what I think OTP is. But really, I think OTP is the key to the magic of the BEAM. You know, when we like to go boast about things, what we really are probably boasting about is OTP. And that's true whether you're writing Erlang or whether you're writing Elixir. So the question is that also true if you're writing Gleam? You know, sometimes you go on internet forums and people say things like, oh, you can't use OTP in Gleam because there's types. And types is inherently something bad to do with, I don't know, actors or something. It can't possibly work. So is it actually still good? Is it actually still magic inside Gleam? And I think yes, a resounding yes. Like, we need to make super clear to people that these things work together brilliantly. We're not going to do it all exactly the same way as in Erlang and Elixir because it is a different set of languages, but it is there. We can use the same framework. So OTP is implemented in Gleam in 2 packages. It's not part of the language, similar to Erlang and Elixir. It's also not part of the language there. It is some modules that probably are shipped with it, but it's slightly separate. There's an added reason why it's separate in Gleam, and that's because we also need to run on JavaScript. JavaScript doesn't have those BEAM primitives, so you can't build OTP on top of it. You could make something inspired by, but it would have to be different. So what are these 2 packages trying to do? Well, we've got a bunch of goals. The first one is to be, productive and production ready. This is really important. There's been lots of attempts to type OTP in the past, but most of them seem to have been academic in nature. The purpose of them is to make a PhD, and if useful programs come out of the side of it, that's also good, but it doesn't really matter. We're not trying to do that. We want people to make real things, and the fact it is functional and typed and all these things, slightly incidental. So similar to Erlang's origin, I think, there. We want to be fully compatible with Erlang OTP. More so, we don't want to be making a separate Gleam OTP. This is Gleam's window into the existing OTP. It's not a second framework that is inspired by. It is the same thing. And we want to be able to use all the good stuff that was made by all the beams that came before us in our Gleam programs. And we want to be good citizens and go the other way around. So we want to make something in Gleam, and then our Elixir friends can take advantage of that. We're all in the same ecosystem together. And we want to provide those core building blocks. So we're going to have supervisors and gen servers and all that sort of good stuff. And here's the Gleam twist. We want to have static type safety. We don't want it to be that those properties you expect when you're writing Gleam code of having type systems and a compiler that helps you and sacrifice a little bit of flexibility in order to get these helpful properties. We don't want to vanish into thin air as soon as we're dealing with concurrency and actors and all that sort of stuff. We need to have both the OTP magic and also the type system magic. And we need it to be as expressive and as capable as Erlang OTP. And I don't mean expressive as in it looks nice, which is some way that some people use the word expressive. I mean in terms of the expressive power. If you can write your program in Erlang, you need to also be able to write it in Gleam. Otherwise, we've made something that is strictly weaker. It needs to be equivalent. And OTP is pretty old. It's coming up to 30 years old, I think. Erlang's about 40 years old, I think. We need to be thinking on these time frames. We're not looking to make something that is here today and then we're all going to move on to whatever the next thing is in 3 years. This should last forever, like our virtual machine, eh? So how do we achieve this? There's 2 different approaches. The first way is to reuse existing APIs. And I'm going to look at supervisors as an example of that. So here is here's the Gleam API for making a supervisor with static children, so we're not dynamically adding and removing children. And if you ignore the fact that it's using this pipeline syntax, it's pretty similar to how it works in Erlang. Semantically, it is exactly the same. It just doesn't have a list of child specifications. It uses a pipeline thing. And because they're so similar, it means we can implement one in terms of the other. So at the top, we import the start link function, which is private, so we don't directly expose it. And then we put this nice wrapper around it that converts from the data structures in the shape that Gleam wants, because that's just how it's nice to work with in Gleam, into the shape that Erlang wants. But other than that, it's exactly the same. And so the point here is that Erlang is really good. We don't have to remake things. If something is there, we should use it, if that's practical. However, it isn't always practical. Sometimes the API just isn't suited to Gleam in some way that we can't easily just gloss over with a small function. And to sort of show that, I'm going to take a look at gen servers for a second. So here is the handle call callback of a gen server behavior module. It's a bit of a mouthful. It accepts 2 messages, incrementing is 0, and it sends a reply back depending on which one it is. Can anyone spot the problem with this code? No? Okay. The first reply is an int, and the second reply is a bool. You can't do that in Gleam. You can't have your case expressions return things of different types. And there's no way to have a union of int and bool. So you can't say this is a case that returns reply of int, pipe, bool. And even if you could, that still wouldn't be good enough in my opinion, because I don't want to say that increment can return bool and is0 can return int. You need to be more fine-grained and split those out somewhat more. So just because something is really good in Erlang doesn't mean that exact same thing is going to be really good in Gleam, and the other way around. They are two different languages with different constraint sets and different strengths and different weaknesses. So you need to design different APIs for the same things to take advantage of those characteristics. So we have to implement something. And OTP is implemented in Erlang. It's not part of the VM. It's not C. It's not cheating. It's normal code. So we need to make sure that in order for Gleam to be as capable as Erlang in this respect, that we need to be able to implement Gleam OTP in Gleam, the same way that Erlang does. And Erlang implements all this stuff on top of a bunch of primitives. These 6 here are the big ones, I think. So if we have the same primitives, we should be able to build up in the same way. Can we do that? Spawn, very easy. Import the function, and we're done. Link, again, import the function, super easy. Trap exits, very slightly more complicated. The function is in a shape that we probably don't really want to work with in Gleam. So we put a tiny little wrapper around it to make it just like a tiny little bit more, Gleamy, what we'd expect. And we can do the same thing for monitor too. So just a one-line wrapper function. That's 4 done, super easy. But the next 2 are the big ones that people get stuck on, especially in these academic projects. Send and receive, probably the most exciting ones. What happens if we try and import them faithfully, using the Erlang design into Gleam? We end up with something like this. And there is another problem. There's no relationship between the receiver of the message and the type of the message. That function definition says you are allowed to send any message of any type to any process, regardless of whether it accepts it or not. And that's sort of the truth of the VM, but that's not what we're aiming for when we're saying we want type safety. We would like it such that you're only allowed to send messages to a process if they accept them. So we're going to need to do something a bit better than that. One thing you could do, and I've seen in some project attempts, is that we could parameterize the PID. So PID now takes a message type parameter, and that is the type of the messages you're allowed to send to it. So for example, if I had a PID of ints, I'm allowed to send ints to it. If I have a PID of strings, I'm allowed to send strings to it. Does that work? So here I've got a very simple program. The user interface process asks for the temperature. It gets back the integer 14. It's 14 degrees, not too bad. And it asks, is it raining? Yes, it's raining at the moment. Okay, we've immediately hit on a problem with this design because the first reply, which is a message being sent back, you can't hide, it's not different just because it's a reply, it's still a message, is an int. And the second one is a bool. So PIDs cannot encode message semantics. It's not flexible enough. If you do that, you end up something that's strictly weaker than regular Erlang OTP. So what can we do instead? Well, it turns out this is a problem that's already been solved by Erlang. If you look inside the gen module, you can find this from data structure, which is a little bit cryptic at first, I think. But it's how they attach this semantic identity information to individual messages inside a process's inbox. And what they're interested in matching up is, what is this a reply to? So we can take this same design and convert it faithfully into Gleam, and we get something like this. And I've just added a type parameter there, which is the message. And so now we've got the from encoding a message identity and also the static type of that message. And it's using things that already exist inside OTP. We're just moving it into a slightly different context. And because we're using it in a slightly different context, a more expanded one, I think the name from is a bit confusing, and the function name reply is a bit over-prescriptive. So we can just rename it to subject and send. But it's still a concept that was already inside OTP. And now we have a way to do typed message sending. I don't really have enough time to go into selector, but it's basically a combination of a few different subjects so you can receive from multiple different subjects at the time. So here I want to I want to receive string messages and int messages, and then I just map the int ones to string using int to string. And then I can pull from different message types at the same time. And that's it. All the primitives. Is that enough to implement Gen Server? Is that enough to be as powerful as Erlang? Well, if we try and implement it, we'll find out. What does Gen Server do? It does a few things. It does synchronous initialization, which is a point where you can either succeed or fail. And at the end of that, you pass some value back to your parent, and where they can do whatever they fancy with it. It holds some state, and you have the opportunity to update and mutate that state throughout the process's lifecycle, and you can handle messages. So there's the system messages, which most of the time we don't want to bother with, but we do want them handled for things like using the observer for debugging, tracing, all that good stuff. And the main two types of messages are synchronous and asynchronous messages, and that'd be where we're going to write the majority of our important business logic code. So how do we implement all these things, given we have the same 6 primitives as Erlang? We can just copy Erlang. We have exactly the same primitives. We can open up the Erlang source, and we can just translate it directly across and just make the little adjustments where we need to. And excuse the absolutely awful slide, but that is pretty much distilled what the Erlang implementation is. Just starts a process, monitors it, and then it waits to see, have you said you succeeded, or have you crashed, or have you told me you've failed, or did you not do anything in time, in which case I'm going to terminate you and move on. Cool. What about on the process side? Well, we receive a message in a loop. If it's a system message, we handle it. If it is an unexpected message, we have to handle it because Gleam forces you to handle everything. In Erlang, we might just crash in this case. This is more akin to how Elixir does it, where there's a default handler, which then, in our case, logs, but you could change it to something else. And then for all the expected messages, we call the message handler function, which has been passed into the single specific implementation from the programmer's business logic, and it will say stop or continue. And if continue, just keep looping and going on and on and on. And then we can try and write that same bit of code from before that didn't type check using this equivalent but slightly different API. And it looks pretty similar. It should look pretty familiar to folks who are used to writing OTP code. The main thing that is different is that we have split out sending the reply to the actual indication to the actor, to the gen server, what to do next. So it's you send the reply to the caller, so that's our replacement for from, that's a subject, and then you continue with the new states. Good. Okay, so I've said it's capable, but is it actually usable for real things? Can you make real-world programs? Well, I think the answer is yes. Gleam's been around long enough that we have real-world evidence of people making non-trivial things, and not just non-trivial things, but making them really well. Like HTTP servers is really exciting. Mist and you are 2 of the fastest HTTP servers on the Beam, and they've been written with Gleam OTP without doing any funny cheating or anything, dipping into other languages. That's brilliant. That shows you can make things that are complicated and make them fast. And we've got database clients, we've got live view style frameworks, PubSub, process registries, all sorts of good stuff. And most excitingly for me, because I want you to go away and write real code, people are making SaaS companies using Gleam. They're writing their business on top of Gleam. So yes, I think it is usable for real things. Go and do it. So Gleam OTP is production ready, it's Erlang OTP compatible, it gives you all the building blocks you need, it's type safe in a bunch of useful ways, and it is fully capable and as expressive as Erlang OTP, and it's ready for the future. So go out and start making some really cool stuff. And that's it pretty much. Also, I should say, Gleam Gathering, Peter's doing a conference in February next year, so come check that out over in the UK. Also, I've got stickers, so please bug me for those. And also, do you have any questions? Thank you very much.
Thanks a lot. Well, let's say we have time for just one question. And there is one question. Okay. In your second implementation of the gen server, you had to explicitly send the reply and set the new state. What would happen if you forget to do any of these?
You can't not set the new states because the type system says you have to return a, what do we call that? I think the actor.continue function returns something called a step. The type system forces you to set a step, so there'll always be some new state. You can opt to not send a reply, and it has the same behavior. it's good to remember that this is normal OTP. All the same rules apply. You can, with a normal gen server, not reply. You can return no reply to a handled call. And in that case, it's probably because you want to use gen reply on the from in somewhere else in the code. But you could just not. And at that point, the caller would time out and crash. So it's exactly the same rules as with regular OTP.
Thank you, Louis.